Okay, so dimensional analysis. Before we start, I want to tell you that when we first start this out, parts of it are going to seem very, very easy. They're going to be conversions you can do on your calculator or do in your head. Okay, I do not want you to do that. I want you to set them up using the units and like I show you. Because I'm going to start out showing you with simple things, but I know what's coming down the pipeline, you do not. Okay, so I already heard someone say it. I don't need to do it this way. I can just do it in my calculator faster. I heard someone say it. Not in here. It was earlier today. I just ignored them and said, whatever. Okay, so please do it like I show you. Because I'm going to start out showing you with simple things, and phones should be put up right now. You should not have headphones in. I'm going to show you with some simple things, and we're going to get more complicated as the year goes. So I'm training you for what's coming. Okay, I know what's coming, you don't. So I'm going to get off my soapbox now, and we're going to start. Okay, so dimensional analysis, sometimes you'll also hear it called unit conversion. Sometimes the old school way is factor label method. Okay, and it's a way that you can convert between one unit and another. Okay, because we can use equivalents. Okay, for instance, how many inches are in a foot? 12. And how many feet is 12 inches equal to? 1. That's a conversion factor. I can use it either way. I can either multiply by it or divide by it, depending on what I want to get to cancel out. Okay? And then, of course, anything divided by itself is 1. Okay? And so if I want to cancel out a unit, and I start out with, say, meters, what do I want to do to cancel out meters? I want to divide by it. Okay, so that's the basis of the method. Okay, so it is going to be, honestly, the most valuable mathematical technique that you can use in here, but also when you go on to physics. Okay, you may not even remember the formula, but if you can get your units to cancel out, if you follow your units, they are your roadmap to get to the correct answer. Okay, so the units are very, very important. They are your directions from point A to point, sometimes D or E, because you got to go through B, C, whatever. Okay. So we're going to start out with something easy. You know how many quarters are in a dollar? We want to know how many quarters would $5.85 be. Okay? So we're going to set it up like this. Okay? Whenever we set it up like this, this is essentially saying times. Okay? It's no different than if I had written 585 times 4 quarters in $1. Okay? It's the same thing. We're multiplying fractions here, okay? And when I multiply fractions, what do I do with the numerator and denominator? I multiply the top, and I do what with the bottom? Divide by it. It's going to be the same concept. The grid, which most of you will end up using because it helps you keep track of the multiple steps. Because we're going to sometimes do 3 and 4 and sometimes more steps at one time. So the grid helps you keep track of everything on the top, everything on the bottom. Sometimes when we do the fractions, especially if we kind of start writing crooked, you can get confused. Also, a very easy way to make sure your units are crossing out. I do not require that you use the grid. You can use it the other way if you want. Okay, but this means times that. So these are your numerators, these are your denominators. Okay? All right, so let's do another one. This one is saying, if you have a 125-pound box, how many kilograms would that be? And it gives you the conversion factor. So we're going to set that up like this. Okay? And our units would cancel out. Pounds would cancel out. So we would take 125. Technically, we're multiplying by 1, but we don't have to do that in the calculator. And we're going to divide by the bottom. Okay? When we write it like this is essentially over 1. Because how do you turn any whole number into a fraction? Put it over 1. We don't have to write that down. If it makes you feel better to write it down, by all means write it down. But anytime we have a whole number, we assume it's over 1 to make it a fraction. Okay? And then, of course, this has 3 significant figures, so we put our answer in 3 significant figures. Okay? Remember I told you yesterday, whenever we use conversion factors, we never let our conversion factors dictate our significant figures. Okay, it's our measured values because these are the conversion factors are exact conversions. They're not measured, or they've been measured so many times, and that's what they chose it to be, the exact conversion. Okay, so pretty much what you start with in the problem, or what's given to you in the problem, will be what you use to determine your significant figures. Okay. So this is just going to take you through, continue to take you through the steps that I just verbally told you, but this is for you to go back and read If you get home and go, what did she do again? You can go by and read the step-by-step process. You always double check that your units cancel out. Okay? So here is an example that we're going to do. It takes 1 egg to make 8 pancakes. If there was a pancake eating contest and the winner ate 74 pancakes in 6 minutes. Okay? At this rate, how many eggs in the pancake would be eaten by the winner in 1 hour? Okay? So what we're looking for is we're looking for eggs per hour. But we have pancakes per minute, per 6 minutes. So we're going to start with what we know, which is the 74 pancakes in 6 minutes. We know that's how much was consumed. So we say 74 pancakes in 6 minutes. So we're going to convert that to eggs per hour. So the first conversion factor that we have is that it takes 1 egg to make 8 pancakes. Also, 8 pancakes uses 1 egg. Okay? I need to get rid of pancakes because I'm trying to get to egg. So what do I need to put on the bottom on the next step? Pancakes. So I'm going to say 8 pancakes, 1 egg. So now that cancels out. So now I'm in the unit on the top that I need, which is eggs. So now I got to get minutes to hours. So I have minutes on the bottom, so where will I put minutes on the next step? On the top. And of course, how many minutes are in an hour? Okay, so I cross out minutes. So my unit now is eggs per hour. Okay, so I'm in the right unit. So now I'm going to multiply the top and divide by the bottom. So you guys do that real quickly. So you get 92.5 eggs per hour. Okay? Yes. I did 74 times 1 times 60 divided by 6 times 8 on the bottom. Now, if you're using this calculator, the easiest way to do these problems is, you see that in the numerator over denominator key? It's like 2 up from 7. See n over d? If you hit that, you can literally type it in like it says. Now, sometimes it gives it to you in a fraction. Actually, it always gives you to any fraction. Then if you go over to the table button, it says F to D. You can hit second that and hit enter, and it'll turn it back into a decimal for you. Okay? All right. Any questions on why I set it up that way? Are we good at the moment?
So basically what you're doing is you're just getting rid of 6 minutes, and then 1 eggs doesn't matter because it's a multiple of 1, and then it's 74 times 60 divided by 8.
No, and 6. Because you have this 6 right here.
Just get rid of the units, don't get rid of them.
Yeah, you don't get rid of the numbers. You get rid of the units, but you got to keep the numbers. You absolutely have to keep the numbers. So that's why we just cross out the units. So there's another way you can do this too. If you don't want to put it in all at once, you can do it step by step. So the way that I normally do it is I would say 74 divided by 6 equals, and then I would say divided by 8 equals, and then I say times 60 equals, and I would get the same answer. That's just the way I learned how to do it, because they didn't have these fancy numerator over denominator keys when I was, way back in the dark ages when I was, growing up and learning to use a calculator. We started to use a slide rule. Just kidding, I had a calculator. We were on the abacus. Just kidding. It's a joke.
They went to the States with this slider rule, though.
No, I had calculator. But we didn't have all these fancy ones that had numerator or denominator, which is actually really good, because honestly, a lot of times kids will have it set up correctly, and then they do the math wrong and they get the wrong answer. So guess what I do for that? Partial credit. So if you have the setup completely right and then you just put it in the calculator wrong, I give you partial credit. Unless you don't have the setup and the units and all that. If I can't tell how you got the answer, then I'm not going to give you partial credit. Okay? All right. So we're going to do 2 of these. And you're going to use your little metric conversions that we've already talked about. So we're going to do 42 micrometers And I want to get rid of micrometers, so where am I going to put it? It's already on the top. I want to get rid of it. Where do I put it? On the bottom. And I'm trying to go to meters. So line up your conversion units, then go put the numbers that go with them. So according to your sheet, how many micrometers are in 1 meter? According to your little, or you can use the one I gave you or the ones in your notes. How many micrometers are in a meter? I heard someone say 1,000,000. So 1 times 10 to the 6 micrometers equal 1 meter. So then I would plug that into my calculator and I would say 42 divided by 1 times 10 to the 6. Now, depending on how you type that in your calculator, if you're using the numerator over denominator, just type it in like that. If you are just doing 42 divided by that, for that calculator you have, make sure you put parentheses around your exponent, otherwise it does something strange. Okay? So you should get 4.2 times 10 to the negative 5th meters. Y'all should do this along with me so that you're knowing if you get the right answer and if you're putting it in the calculator correctly. Okay? There are other ways to do this. If you want to use the negative exponents and say that there's 1 times 10 to the negative 6 meters in 1 micrometer, you are welcome to do it that way. It would still give you the same answer, but I'm just telling you as a general rule, kids work better if they keep their exponents positive. There's already enough negativity in the world. Okay. 33.9. I'll have to help you at the end because I'm recording. 33.9 picometers. Okay, I want to get rid of picometers. So where am I going to put it? Bottom. And I'm going to meters. Okay, picometers is one on a test that I would give you right now. Okay, because I'm only asking you to memorize that box. So I'm going to tell you that there is 1 times 10 to the 12 picometers. Now, on your homework, you'll have to look that up, but right now I'm just going to give it to you. So, per 1 meter. So I'm going to take 33.9, and I'm going to divide it by 1 times 10 to the 12. And I will get 3.39 times 10 to the negative 11 meters.